We are together with a good Olympic question. US 3 to the x plus 9 to the x plus 27 to the x is equal to 14. Now here given the different forces of 3. Let's try to write them all in 3 bases, using the properties of exponential number. By replacing exponential forces with x, let's try to get a different equation. And if we continue from here, a different equation will come out. If we say 3 times x to a, our equation is suddenly turned into a third-order equation. Of course, the roots of the third-degree equation, providing x. Different methods to find values we apply. Let's move on to them. Last, we have a cube plus a squared plus a minus 14 equals 0 equation formed. Now, if we say 3 to the xa, and after applying it in the equation, to make our question more solvable, we need to add and subtract some terms. Before us, second degree equations and third-order equations separately. We can solve the question by separating the roots. Our aim here is to bring algebraic expressions with common factors. When we continue, that wasn't enough. In this case, the rest of this quadratic equation, first degree again. We are trying to add terms. If you pay attention, there is no change. The equation we found here, within a minus to algebraic expression will come in common. Then this whole expression a minus 2. If we take it to the common multiplier bracket, we get a minus 2 times a squared plus 3 times a plus 7 is equal to 0. Now examining these two given equations separately, let's try to find the values. If we continue, like what? Expressions will come out. Let's see. Now a minus 2 is equal to 0 and a squared plus 3 times a plus 7. So we get the equation equal to 0. Now we need to examine the roots of this equation. We see that this quadratic equation is not simply broken down into its roots. So let's try to examine the delta first. What was delta first? Let's remember it. We could find delta with b squared minus 4 times a times c, or discriminant. This is how we could find the expression we call. Then let's try to calculate the delta of this equation. Our delta, when we look, minus 19 will be less than 0, so the value that provides a real number does not exist. In this case, us. From the equation a minus to equals 0 we found at the beginning, we need to continue on the road. Let's examine it now. Then if we continue the question over this value, let's see what will come. A minus 2 is equal 0. A is equal to 2 from here. What we call a. What was the algebraic expression? At the beginning of the problem, we accept 3 to the x is equal to a. We tried to solve this equation by changing the variable. Now here we have x given as the power of the number 3. What should we do? Gotta leave it alone. An exponential function. To pass the inverse of an exponential function, we need to do logarithmic operations. In this case, let's take the logarithm of both sides, but we need to dictate which number base we get. Logarithm is equal to 3 bases x. Logarithm is equal to 2 in 3 bases. This exponential force given here, times will come in front of the logarithm, and our logarithmic expression will last in this form. Let's say the bases are the same or so. We know that the logarithm base 3 is 1. And our solution here, x in the logarithm base 3, we can easily say that there are 2. If you like the video, don't forget to like it. If you have different solutions, you can write it in the comments. Share it with your friends. Nice question. Stay in math. See you. Bye-bye.